Hi, everyone. Welcome to FM Deep Dive, a facilities management production created with the help of AI. Today, we're diving into the people, projects, and work that keep the University of Maryland campus running.
Welcome to today's Deep Dive. We've got this fascinating stack of sources in front of us today. Environmental reports, grant breakdowns, university project notes.
Yeah, a lot of really detailed ground-level data.
Exactly. And our mission today is really unpacking the recent Campus Creek restoration project. We want to understand how fixing just one single campus waterway creates, these massive ecological ripples.
Right, the ripple effect is huge.
I mean, think of a creek suffering from severe chronic high blood pressure. The pressure gets so intense it's just blowing out the vessel walls, and the entire system is threatening to fail.
That high pressure was literally tearing the landscape apart. Because to appreciate the cure, we really have to look at the disease affecting that stretch of creek running from Oakland Hall down to Paint Branch.
Right.
For years, these intense stormwater surges were basically acting like a fire hose on the creek bed, just constantly blasting it.
Which, that always sounds a bit counterintuitive to me. Like, water naturally flows through a creek anyway, so why are these specific stormwater surges suddenly the bad guy? Why are they tearing up the habitat?
Well, it really comes down to velocity and volume. Under natural conditions, soil and vegetation absorb the rain and then release it slowly.
Sort of like a sponge.
Exactly like a sponge, but a modern campus is covered in impervious surfaces, concrete, asphalt, all of that. So when it rains, massive volumes of water are funneled directly into the creek all at once.
Oh, I see. So that unchecked surge velocity is what actually scours the banks.
Yeah, exactly. Instead of just depositing nutrients to nourish the habitat, the sheer force strips the biological layer totally bare. And that sends all the sediment crashing downstream.
So the ecosystem's blood pressure is spiking, and that's where facilities management, or FM, steps in to essentially perform the surgery.
Right, and they came armed with a $1.7 million grant from the Maryland Department of Natural Resources.
Wow, okay. And FM didn't just go in and clear out some debris, right? Reading these notes, they completely overhauled the creek's structural anatomy.
They really did. They finished this multi-phase intervention just this past January, and it fundamentally altered how the water behaves.
How so? Like, what did they actually physically change?
Well, first, FM regraded the creek bed. They essentially flattened the slope to just physically slow the water down. Then they stabilized the failing banks and planted all these fresh shrubs and trees.
Right, because those new root systems act like underground rebar, basically locking the soil in place.
That is exactly what they do. And the project went beyond just the creek itself, too.
Oh, you mean the retention pond? The one near the Animal Sciences building that catches the agricultural runoff.
Yeah, that one. FM transformed that static pond into a functioning wetland system to pre-filter the runoff.
Okay, so they basically built a natural obstacle course, like speed bumps and biological filters just to tame the water.
An obstacle course is a really perfect analogy because before the runoff even hits the creek now, it has to move through this new wetland.
Oh, and the wetland plants physically trap the sediment in their roots.
Exactly. While microorganisms in the soil break down the excess nitrogen and phosphorus from the farm runoff, it is basically a living treatment plant.
That is incredible. And we are already seeing the local habitat bounce back from this. The sources say the water is noticeably clearer, wildlife is returning to those restored sections, and obviously the university gets new recreational spaces out of it.
Right, new research spaces too.
But I do have to push back a little on the regional claims in these reports. It's wild to suggest a small campus pond retrofit can actually protect something as massive as the Chesapeake Bay.
It sounds like a stretch at first, sure.
Yeah, like, does a localized fix really make a measurable dent? Or is that just, a nice PR talking point?
Well, it seems disproportionate until you look at how watersheds actually amplify pollution. Because a massive body of water like the Chesapeake Bay is entirely dependent on the health of its thousands of tiny upstream tributaries.
So if one small part is sick, it spreads.
Exactly. If a campus creek dumps sediment and nitrogen downstream, that pollution doesn't simply dilute in the ocean, it compounds with every other degraded creek.
Oh, causing those massive downstream algae blooms we hear about.
Yeah.
And the dead zones.
Yes. By trapping the pollutants and slowing the water right here at the source, this interconnected creek and pond system directly improves the water quality draining into the Anacostia River and ultimately the bay.
So you stop the bleeding at the capillary level, so to speak, so the main artery survives.
That's a great way to put it. FM strategic grading and planting reversed years of erosion. They basically engineered a solution that uses living biology to restore both the local wildlife and the broader regional water health.
It really makes you look at the entire landscape differently, which I think leaves you with something to ponder the next time you're just walking around.
Definitely.
What other hidden, everyday campus infrastructure around you might secretly be acting as an engineered ecosystem, just quietly protecting the broader environment without you even noticing?
You've been listening to FM Deep Dive. To learn more about facilities management projects at the University of Maryland, visit facilities.umd.edu.